You said you hate Cambridge with all your heart and soul. All right, okay. Okay, so we've got these 40 members. We've got Ranuf and Saeed. All 40 members travel to the concert. 35 members will travel on the coach. Another 5 travel in the car. Ranuf will be in the coach and Saeed will be in the car. How many ways can the members who will travel in the coach be chosen? Okay, so what was your thinking about this one? Let's got an idea here. Don't get shy now. Yeah, what do you think, Kenny? Accounted for? Yeah, Ranuf is already in the coach, so there's only 34 spots left. So you just chuck that in the calculator and you get this as your answer. So that's your 3 marks. That seems quite simple, really. If only we got something like that in the actual exam. Okay. This also is another type of question we have here, similar. 3 blue candles, 2 red candles, 6 green candles, and they're identical apart from their colours. So if they're identical, that means that, if you have red, green, red, that's the same, whether you swap the reds around. And he's arranging 11 in a line for some reason or other, as you do. And we've got to find the different arrangements of the 11 candles if there's a red at each end. So what I would probably do is this, let's go red. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there's a red here. So there's 9 in the middle, and there's 3 of them are blue, and 6 of them are green. So we're going to arrange those 9 spaces, but because there's 3 that are the same, and then there's 6 of the same, we're going to do like that. 9 factorial divided by 3 factorial times 6 factorial, and we chuck that into our calculator, and what do we get for that? Yeah, so that's 84. Okay. The next one, find the number of different arrangements of the 11 candles if all blue candles are together and the red candles are not together. So sometimes you have to do these the opposite of what you're thinking or what you're trying to get. So this is what I'm going to do. How many greens have we got? This is 6. So I'm going to think of it like this. Now, if the blues are together, we can count them as like one item. And then we've got to rearrange everything else. Now, I decided I'm going to rearrange everything else with the reds together. Okay? Because then we can do the total number of arrangements and then subtract the arrangements where the reds are together, and that should give us the ones where the reds aren't together. So that's a strategy I would use in this case. So the arrangements when the reds are together is, how many items have we got? 1, 2, 3, 4, 5, 6, 7, and then the reds are the 8th. So it's 8 factorial. But then we're going to divide that by 6 factorial. We don't worry about the reds and the blues because we're treating them as 1. And so 8 factorial divided by 6 factorial. And this should give us 56. So that's the number of ways that we can arrange it with the reds being together. Now, what are the total number of ways we can arrange it when the blues are together and the reds aren't necessarily? Total arrangements? Yeah, what are you getting at? Can you explain why? Yep. Okay, and so that gives us, what is that, 620? Wait, sorry, 252. 252, sorry, 252. Okay, and then the final step is to go, all right, then the ones where the reds aren't together should be 252. Take away the 56, which is giving us 196. Okay, so this is reds together, and this one's total arrangements. Okay. All right, so that was pretty much all of the stuff from March 2020. And now I've got a nice, easy one. I like these letter ones. I feel like they're a good deal. We're trying to make some different arrangements from 9 letters of the word jewelry, in which the 3 E's are together and the 2 L's are together. So we could make it like this. We could go E, 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 and we'll treat that as one item. And then we'll put the 2 L's together, L, L, treat that as one item. And then the only other letters we've got is J, W, is R, and Y. Okay, so how many items have we got all together if we're treating the E's and the L's as one item? What do you reckon? So the ways we can arrange it? 6 factorial, so 720. Okie dokie. Now, moving on, find the number of different arrangements that can be made from 9 letters of the word jewelry, in which the 2 L's are not next to each other. So, why don't we find the total ways? What are the total arrangements? Anyone want to hazard a guess on how we do that? Yep. Yes. Do you want to explain that, please? 9 factorial is? Yes. Yep. And what's that? 3240. And then we're going to subtract from that the L's next to each other. So what are the L's next to each other going to be? Well, we can go LL, we'll treat that as one, and then all the other stuff we'll treat as individuals. So how many items have we got all together here? Is it 8? 8. So it's 8 factorial. And then what are we going to divide by? Because we do have some double ups. What do you reckon, Thomas? Perfect. And we're not bothering with the 2 factorial. Why not? Anyone? Yep. Yeah, we treat the L's as 1. So just leave that there. Now this gives us 6720, 6,720. And we've got to follow this formula here. We're taking total arrangements, subtract the L's next to each other. So we're going to go 30,240, take away 6,720. And that will give us our final answer, which is, you know, perfect. Okay. Oh, here we go. In a music competition, there are 8 pianists, 4 guitarists, and 6 violinists. Now, we're just going to assume that none of these is Timmy and playing all of those 3 instruments at once. Right? 7 of these musicians will go to be selected through to the final. How many different selections? So selections of 7 finalists can be made. We need at least 2 pianists, at least 1 guitarist, and more violinists than guitarists. So let's think about the different options we have here. I will set up a little table here: pianist, guitarist, violinist. So we need at least 2 pianists, so we could have 2, and we need at least 1 guitarist, so 1. Now, if this is the case, how many violinists must we have? Should be 4. Now, we could go 2 pianists and 2 guitarists, couldn't we? Because that fulfills that. And in this case, we'd have to have 3 violinists. But we can't go 2, 3, can we? Why would we not be able to do that? Right, so that one's not going to work for us. We could up our pianists to 3. And that means we could put in one guitarist here, which is 4, and then we'd need 3 violinists. Could we go 3 violinists, 2 guitarists, and 2 violinists? Sorry, 3 pianists. So we could go 3, 2, 2. Could we do that? Why not? Yeah, more, not the same. Okay, so we can't do that. There's one more that we can do. Can anyone see it? Four, 1, 2. So those are the 4 ways that we can fulfill this. And what we want to do is figure out how we do this. So the first one, there are 8 pianists, and we are choosing 2 of them. And the guitarists, and we're timesing here, aren't we? Not adding a number of you added in the stats exam. We are choosing 1 from the 4 guitarists, and we're choosing 4 from the 6 violinists. And what does that give us? Cool. And then in the second one, do you want to, want to hazard a guess to what we're going to write for this? Maybe Pazia, you think you know? And Pakawa, what does that give us? 3,360. Yeah, 3,360. And the next line, Kanak, what do you reckon? Anyone got that? And then finally, Thomas? Yep. And 4,200, I think. And then we add to find total. Yep. So I think the hardest part of that question was figuring out the different combos that would fit the criteria. And once you're there, it's just a matter of selecting. Why are we not using P? Why are we using choose? The order doesn't matter. Yeah, exactly. Okay, when the order matters, snap. When the order matters, then we need to use P. Okay. June 5.2, summertime. Okay, we need an E at the end and an E at the beginning, just because. Why not? And then that means we've got 1, 2, 3, 4, 5, 6, 7, 8, and then we've got an E at the end. Now, we've got 8 in the middle, so we're going to rearrange those. But with the 8 in the middle, so we've put an E in, are there any double ups of any letters? You can see some. M. Anything else? I think it's just M's. And how many M's have we got? 3, so 3 factorial. And that gives us 6,720. Find the number of different ways in which the 10 letters of the word sometime can be arranged so that the E's are not together. What's our strategy here? Total ways. Subtract ways the E's are together. That's the strategy for this. Now let's see, what are the total ways? Thomas, what do you reckon? Yeah, good man. All right. And then what about the ways when the E's are together? So if we take the E's and put them together, how many other letters do we have? Is it 8? I think it's 8. So, but 8 other letters, and then we treat the E's as 1 letter. So it's 9 factorial. So we're going to take away 9 factorial. And within the other letters, there are 3 double ups. That's the M's. So that? 9 factorial divided by 3 factorial. We chuck that into the calculator. Anyone got an answer on that? I've got a different answer when I wrote this before, but I may have made a mistake. Yeah, I got 241,920. 241,920. What happened? Did you just do one of them? Yeah. Okay. Moving on. 4 letters are selected from the 10 letters of the word summertime. Find the number of different selections. Okay, so this is a selection one. Include at least one M and exactly one E. Okay, so let's write down the different ways we could do this. We have to have an E, and we could have at least one M. So EM something something. What's another way we could fulfill this criteria? EMM and then something. And finally, we could have E and then all of the M's. Now, there's only one way of doing that. One way. What about this one here? If we select the M's and we're not selecting anything else, so just think of our word summertime. We're not choosing those. We're not choosing that. We're not choosing that. And we're not choosing that. How many letters have we got to choose from left? 5, isn't it? Those 2 and those 3. So we would say this is 5, choose 1, which is equal to 5. That is not 5. That's 5. Okay. And this one at the are you okay with that, Pakawa? Yeah. And the top one, we've got 2 letters to choose, and we're not allowed to choose any M's or any E's for this one. So we've still got those 5 letters to choose from, but this time we're choosing 2 of them, which is 10. And so the total ways equals 16, because we can just sum, bless you, sum ways. Okay. Any questions? What, are you okay with that? You're looking like Marcia? Yeah. Okay. Celestial. Find the number of different possible arrangements. So we've got 9 letters. So it's 9 factorial. Are there any double ups, Pakawa? Two L's as well. And so this is 90,720. Don't make, see it's a 1 mark, because you don't want to lose the mark on that one. Find the number of different arrangements of the 9 letters in the word celestial, in which the first letter is C. Okay. And the 5th letter is T. So 1, 2, 3, 4, 5. And the last letter is E. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So if you think about our word here, get rid of that, get rid of that, get rid of that, and those are the ones that we've got left. And we've got 1, 2, 3, 4, 5, 6 spaces to fill. And we've got how many different letters? We've got our 6 different letters. So lesial is left. Okay, so there's 6 different letters. And so we can arrange them in 6 factorial ways, but there is a double up of the L's now. Okay, why is there not a double up of the E's anymore? Because we've already placed the E, right? So it's not there to put into our way. Okay, that ends up being 360. Find the probability that a randomly chosen arrangement of the 9 letters in the word celestial does not have E's together. Okay, So again, what's our strategy for this? Total. Subtract ways with ease together. But this one's a bit different because we've got to do probability at the end. Okay, who reckons they know how to do the total ways? Didn't we do that actually in part A? What was that? 90,720? Now, what about the ways with the e's together? So you could think of this like EE and then CLSTIAL. That's 1. And so altogether it's 8 factorial, is it? Divided by 2 factorial. Okay, now this gives us the ways with the e's not together, which is 70,000, I think, 560. And to do the final bit, which is the probability, yeah, 70,560 over the total, yeah. And you know you're right when you put that in the calculator. Something's worked out well there, hasn't it? Okay. Yeah, probably if you showed that you subtracted it, that would give it to you. And now we're going to do 5 letters are selected at random. And we've got, here's one of these ones again. You've got to include at least one E and at most one L. So E, and then 1, 2, 3, 4, that's 1. Another way you could do it is E with 1 L. What's another way we could fulfill this criteria? Hazia? Yep. Or 2 E's and no L's as well. So that one and that one. Is there anything else? I can't see anything else myself. So let's consider this first one here. Now remember, let's look at the words celestial. So we're not going to be using any of that or that or that. So how many letters have we got left over? Is it 6? 5. 5, sorry, 5. Okay, so the first one is going to be, what do you think there, Nasia? Yeah. And the next one? Oh, what does 5 choose for? Okay, and Kenny, the next one? What do we get for that? And the next one should be 5 choose 2. And then the last one. So the total is 35. That was actually not too bad.